Stoichiometry uses molar ratios from a balanced equation to predict the amount of products a reaction will produce. It can also tell you how much of a reactant is needed for a desired amount of product. You can think of a balanced equation like a recipe. If you know how much is going in, then you know how much should be made or coming out. In our example here, we have a cheese sandwich recipe. There's lots of recipes for a sandwich, but we're going to go with 2 slices of bread plus 1 slice of cheese equals 1 cheese sandwich. So if we have 10 slices of bread and excess cheese, how many cheese sandwiches can we make? Well, the first thing, anytime you see excess, excess means extra. So the only thing we care about in this problem is our 10 slices of bread. So we have 10 slices of bread and we want to know how many cheese sandwiches we can make. You could do that in your head, I'm sure, but we're going to solve that with dimensional analysis. So we're going to solve it just like we've been solving problems. And say 10 slices of bread. Whatever unit is here is going to go down here. So we're going to have slices of bread, and we're going to go to sandwiches. To find that ratio of how many slices of bread to how many sandwiches, we look at the balanced equation. 2 slices of bread for every 1 sandwich. So 2 slices of bread for every 1 sandwich. Dividing that, we get 5 sandwiches. So let's try this next one. We have 6 slices of cheese, excess bread, so we don't care about our bread, and we want to know how many sandwiches we can make. So 6 cheese, we're converting cheese to sandwich, and from our recipe, we know that we need 1 cheese for every 1 sandwich. So if we have 6 slices of cheese, we should be able to make 6 sandwiches. Go ahead and pause the video and do number 3 on your own. Restart when you're done. So in this problem, we start with our 15 cheese sandwiches. So you can either be given a reactant or a product to start with. It doesn't matter. And we're trying to find out how many slices of bread we needed. So we go sandwich to bread. And there's 2 bread for every 1 sandwich. So that means we're going to multiply, and that gives us 30 bread, or 30 slices of bread. This last one, it doesn't tell us which one we have extra of. It says we have 14 slices of bread and 5 slices of cheese. How many turkey sandwiches can we make? So you're going to start this one with 2 conversions, so 14 bread and 5 cheese. And convert both of those to sandwiches. Restart when you have your answer. So here it says we have enough bread to make 7 sandwiches and enough cheese to make 5 sandwiches. So would I make 7 sandwiches, 5 sandwiches, 2 sandwiches, 12 sandwiches? How many sandwiches can you make? Well, we would run out of cheese after 5 sandwiches. We can only make as much as the smaller amount of product. Cheese is our limiting reactant, and bread is our excess reactant. We're going to talk more about limiting and excess tomorrow, but the limiting reactant is going to limit how much product we can make, while the excess you have extra of. We can see that here as well. If I had 6 pieces of bread and only 2 pieces of cheese, I could make only 2 sandwiches. Notice I would have extra bread left over. I can't make another sandwich with that bread, so leftovers are my excess. Or if I had a lot of cheese and only 2 slices of bread, I can only make 1 sandwich. Well, if I added more bread, I could make another sandwich. And if I had an odd number of bread, I could only make still 2 sandwiches. I would have bread and cheese left over in this case because I couldn't make a sandwich with only one piece of bread according to my equation. Let's see how this goes with reactions. So given your reaction, the reaction is telling you that when you have one molecule of nitrogen, because there's no coefficient, it's going to combine with 3 molecules of hydrogen to produce 2 molecules of ammonia. The number of molecules also refers to the number of moles. So we can compare the number of moles of a compound that goes with the number of moles of a compound of a product. So according to the reaction above, 1 mole of nitrogen combines with 3 moles of hydrogen to produce 2 moles of ammonia. We can solve these problems exactly like what we were doing a second ago. We're going to start with our 6 moles of NH3, and we're trying to go to moles of nitrogen. It's always a good practice to either underline or box in what you're looking for and what you're given. So I have 6 moles of NH3. I set up my chart. I'm going to put my units first, so moles NH3, and I'm going to moles of nitrogen. Anytime I have moles over moles, I'm going to look at this balanced equation because I need to know how they react. So for every 1 mole of nitrogen, I have 2 moles of NH3. So dividing that, I get 3 moles of nitrogen. Let's look at one more. We're going to still be using the same equation up on the top. So step 1, I have 9 moles of hydrogen, and I'm trying to go to moles of NH3. So 9 moles of hydrogen, moles hydrogen, moles NH3. I look up at the top, and for hydrogen, I should be putting a 3, and for NH3, I should be putting a 2. Again, those numbers are coming from the balanced equation, a 3 and a 2, just like they came from the recipe a minute ago. So multiplying and dividing, I get 6 moles of NH3. Alright, go ahead and pause the video and try the next one on your own. Restart when you're done. So on this one, we had the same ratio as the previous problem, but we had 2 NH3s for every 3 hydrogens. We get 6.75, but in 2 sig figs, we get 6.8. Remember, for sig figs, you're looking at the beginning number, and we had 2, so our final answer should have 2 sig figs. Go ahead and try this last one on this page. Restart when you're done. So we started with 8 moles of hydrogen, and we're trying to find moles of nitrogen. According to our ratio up above, there's 3 hydrogens for every 1 nitrogen. So dividing, we get 2.666, which rounds to 2.7 moles of nitrogen. Before you can solve any of the problems, if your equation is not balanced, you're going to need to balance the equation before you can solve, because this ratio comes from the balanced equation. So step 1 is always balance your equation if it's not already balanced, and then you can start solving.